Welcome to the course about the technologies used in Agriculture 4.0. In this course, we will focus on drones. The word drone is an everyday term for unmanned aircraft vehicle, UAV, or unmanned aircraft system, UAS, a pilotless aircraft that is controlled either by a remote pilot or flies automatically. Drones in agriculture have several advantages and are one of the main tools that advance precision farming and agriculture. Precision farming and agriculture is the science of using technology to increase efficiency, productivity, crop output, and profitability. Through drone photogrammetry, drones can assist farmers in building extremely precise maps and 3D models of their farm. Through the usage of drone mapping software, images taken by drones are stitched together to create a topographical map of the area. Drones can work with a variety of cameras depending on the kind of data that the farmer needs, for example, multispectral cameras, thermal cameras, etc. There are mainly two types of drones that are widely used in the agricultural sector: fixed wing and multi-rotor. What kind of drone is suitable for your tasks? Depending on what kind of task you want the drone to do, you should choose between a fixed wing and a multi-motor. Large drones will lift heavy loads while small ones are easier to navigate and perform photogrammetry. When you make your decision, assessing flight time and payload is important. In order to fly UAS in the open category, it is mandatory to pass theoretical exams with a minimum grade of 75%. All remote pilot certificates are recognized and accepted in all EU members. Furthermore, the remote pilot can choose in which EU member state to conduct the training exam. CE marking indicating that the product has been tested and meets the specific requirements shall also be visibly affixed to the frame of the UAS. Furthermore, agricultural meteorology draws on basic physical and biological sciences to discover, define, and apply knowledge of weather and climate to the production of food, feed, fiber, and bio-based products. Agricultural meteorology is based on fundamental principles of radiation and surface aerodynamics and thermodynamics. For any farmer or professional working in agriculture, the benefits afforded by digital technology can be of huge advantage to crop management. Monitoring local and global weather patterns is critical to helping farmers to prepare for the worst when extreme weather is likely to hit. A special branch of meteorology that supplies drone owners and operators with weather forecast is called aeronautical meteorology. Weather conditions affect almost every aspect of our lives. Until the development of computers and smartphones, hydrometeorological institutions informed general public about the weather forecast through available media. Today, weather forecast is available through apps that can be easily downloaded to the smartphones. This fact facilitates the work of a drone operator who can easily obtain information about weather conditions in real time. A drone operator poses an increased risk to people and objects on the ground, and therefore she must have extra knowledge about how the weather and meteorological conditions affect drone and flight. An adequate water supply is important for plant growth. When rainfall is not sufficient, the plants must receive additional water from irrigation. Various methods can be used to supply irrigation water to plants. Each method has its advantages and disadvantages. These should be taken into account when choosing the method which is best suited to the local circumstances. Sophisticated methods of water application are used when larger areas require irrigation. There are three commonly used methods: surface irrigation, sprinkler irrigation, and drip irrigation. The new era of irrigation is the automatic. Automatic irrigation is the use of a device to operate irrigation structures so the change of flow of water from bays can occur in the absence of the irrigator. Automation can be used in a number of ways. To start and stop irrigation through supply channel outlets, to start and stop pumps, to cut off the flow of water from one irrigation area, either a bay or a section of channel, and directing the water to another area. These changes occur automatically without any direct manual effort, but you may need to spend time preparing the system at the start of the irrigation and maintaining the components so it works properly. The benefits of automatic irrigation are the reduce of labor costs, the timely irrigation, plants being watered when needed, the management of higher flow rates, the accurate cutoff of water compared to manual checking, the reduced runoff of water and nutrients, the reduced costs for vehicles used to check irrigation. Precision agriculture sensors are very efficient in agriculture because they transmit data that helps farmers not only to monitor but also to improve their products and keep abreast of changes in the field and ecosystem. Intelligent agricultural sensors help to easily identify animals, detect heat and monitor their health, thus facilitating the isolation and healing of sick cows by identifying, detecting, and following herds. Using smart sensors in agriculture, farmers can now record their crops and keep an eye on their effectiveness remotely, address crop pests and take swift action to protect their crops from any risk to the environment. What type of sensors are used in agriculture? In Agriculture 4.0 we have optical sensors, electrochemical sensors for soil nutrient detection, mechanical soil sensors, dielectric soil moisture sensors, location sensors, electronic sensors, airflow sensors and agriculture sensors IoT. With the increase in adoption of the Internet of Things, the ability to connect various devices have been implemented in virtually every aspect of our life. It only makes great sense that automation also finds its own application in agriculture, as it will have a great impact on it. This sensor provides real-time information on what is happening on the field, such information including air temperature, soil temperature at various depths, rainfall, leaf wetness, chlorophyll, wind speed, dew point temperature, wind direction, relative humidity, solar radiation, and atmospheric pressure. This indicates that farmers are in the know-how of when their crops are due for harvest, the quantity of water being used, the soil health, and if there's a need for any additional input. This is measured and recorded at scheduled intervals. There is a big list of sensors used in agriculture, IoT sensors, which means solutions for smart farming. Making use of precision agriculture sensors will definitely transform the agricultural industry by increasing crop production, adopting a pest-free high-yield variety in crops, and keeping up with the increasing demand for food. Congratulations on completing the Drones in Agriculture 4.0 course. Throughout the course, you gained a comprehensive understanding of how drones are revolutionizing modern farming practices and contributing to increased efficiency, productivity, and sustainability. Remember, Agriculture 4.0 is an ever-evolving field, and staying at the forefront of innovation is key. We encourage you to continue exploring and expanding your knowledge in this exciting domain. Thank you for your dedication and commitment to learning. Stay connected with us for future updates and resources.